In this video, we're going to talk about functions. Now, functions are something we've talked about before and used a lot in our programs, but basically we've just been using the functions that have been built into Arduino or that we've imported from a library. So like an example of this is right here, serial.begin. We are calling a function that is defined by Arduino that has some other code associated with it behind the scenes, where our Arduino will jump to and execute the various pieces of code that are associated with this single line here. So this is what's known as a function call, and then it jumps to the definition of that function and runs all the code associated with that. So functions are meant to be this like smaller subcomponent of our program. They're meant to be kind of this black box that performs a single task. So like serial.begin is this black box that we can tell it, all right, we want you to set up the baud rate or the communication rate to be 9600, and we can kind of just expect it to do its job. It's already been defined for us behind the scenes and it's done it. What we're going to talk about more here is how to define our own functions. So we've always been defining our own functions here for setup and loop, because that's what Arduino has told us to do, right? In order to be able to write a program, we write some code inside of setup and define what setup does, which is the thing that runs once at the very beginning. And then here what we do is we write code inside of loop and define what loop does, and it runs over and over and over again. But we are going to more specifically set up other functions for different tasks that we can call at any point throughout our code. And so we've been working a lot with this example, creating a better way of controlling the speed for a servo than just telling it to write to a specific angle and have it run as fast as it can to that angle. We've been looking at doing it with various different types of loops. And so here I have the example that we worked through where we created a for loop to iterate through or loop through all of our different possible angles from 0 up to 180. And then we printed out the angles as well as writing it to that angle and waiting, some specified amount of time between each angle so that it'll move a little bit slower and not as jerky, and we can we can dial in the very specific speed at which we want it to move. So what we could do is we could bake this into a function. We could bake this into this black box that we can kind of understand how it works and share some information back and forth. So some functions have what are called arguments. These are values that we are inputting into the function. So that would be like for serial.begin, our input argument is 9600, which is the speed at which we want it to communicate. For myservo.write, we have an input argument for the angle that we want it to go to. For delay, we have an input argument for the number of milliseconds that we want it to have. There's another servo function is servo.read, and what that does is that returns back some information from the function. So functions can both take some values as arguments, as inputs to this black box and then do something with it, and then some of them can return back information, and we call these things return values. So myservo.read returns the current position of our servo. Other examples of things that give us return values is like digital read or analog read. Those both give us the values that we read from that pin. And so those are a couple of the different things we can define, right? So functions can have arguments. These are the inputs to it, and it can have 0, 1, or many different arguments. And then functions can also have return values. They don't have to have a return value, but they can, but they will only have a single value that it returns back. So let's look at how we could bake this functionality here into a function. So what I'm going to do is I'm going to come down here and I'm going to write a function, and in order to be able to call a function, we have to come up with a unique name or identifier for a function. So we're just going to call this servo move, let's say, and this is our name for it. And then what we need to do is in front of the name, we need to put the type of the value it's going to return. And so in front of setup and loop, you can see that there's the word void, and that means that these functions don't return any sort of value. And I think for our servo move, we're not going to have it return any value because we're just going to expect it to go to the position that we're telling it to go to. So that's what we'll do here is I will put the word void here, and then we will define servo move. And then inside of here, what we can do is we can define the values that we are going to pass to it, these inputs or these arguments that we're going to provide to it. And so I think there's a couple of pieces of information that are helpful here. One is going to be the angle we want it to move to. So what I can do is I can say, okay, let's create some input argument. The type of that input argument is going to be an int, an integer variable, and then we'll give it a name and we'll call it angle here. All right, and then I'll put a comma to separate my various values. And then what we will do is we will have our delay, like how long we want it to delay between each degree that it is moving to, so that we're kind of controlling the speed here. So I'm going to say int, again, because it's some integer whole number value, and then we can call it ms per degree, right? Because it's how many milliseconds it's taking for every degree here. And then what we'll do is we'll put curly braces here, or curly brackets here. And so what's going to happen is in between those curly brackets is where we're going to write all of the lines of code associated with doing this servo move functionality. Okay, so what we're going to do is we're going to try to incorporate this code inside of here, and then just be able to call servo move and have it do that functionality whenever we want it to. All right, so let's see. We have the angle that we want it to go to, and we have the number of milliseconds per degree that we want it to delay for. But what we don't have at the present moment is its start position. And I kind of mentioned this a little bit earlier. What we could do is we can use myServo.read to get the initial position of the servo, where it's currently positioned. So what I'm going to do is I'm going to store that to some integer variable, and I will call that initial position, like this, and we will set that there. And then what we can do is have it move from initial position to angle, or actually let's rename this target position, because I think it'll make a better example, and I'll explain that in a little bit later on. But we want it to go from initial position to target position in steps of 1 degree at a time, while delaying for this amount of time before that. And so you could think, hey, maybe we could just copy this here and make that happen. So if I copy this to here, this is our for loop where we set up some control variable called angle to start at one position and go all the way up to another position here. And so let's think about it. Our initial position here isn't going to be 0. It's going to be the current position of the servo right there. So what I'm going to do is I'm going to say int angle equals initial position, and then we're going to continue to add 1 to the angle up until we get to our target position. So I'm going to copy this variable and put it right there. And this looks good to me. This looks like a good way to set up this for loop here. And now angle is going to go from initial position all the way up to and including target position in steps of 1, where it will print out that value, go to that position, and right now it's delaying for 50 milliseconds. And that's not quite what we want. We want to be able to define it and change it so that it's not always going to be that fixed amount of time. And so what I'm going to do is I'm going to put the argument milliseconds per degree right here. And so what you'll see is that when we call this, we're able to identify the target position and the milliseconds per degrees that we want. Okay? And so we're getting close, and this would work for like half of our cases, right? This is going to work when the initial position is less than the target position, because we're increasing the angle each time. So the initial position would have to be less than the target position. But it's not going to work if we're doing this last case here, where we were, say, going from a larger angle to a smaller angle. So we need to add another case for that here. All right, so let's copy and paste this and put it here. And we'll say this is going from smaller angle to larger angle, and this one here would be for going from a larger angle to a smaller angle. Okay, and so let's change this part up here. So our angle again would start at initial position. It would go down until it is until the variable angle is no longer greater than or equal to, in this case, our target position as opposed to 0. And then we're going to subtract, because we're saying here the initial position is greater than or equal than the target position. All right, and then what we would do is we would say, okay, let's print that angle. Let's go ahead and write that angle to our servo as we're going down in steps of -1 each time. And then again, we need to change this delay here to not be 50 milliseconds, but be this value that's passed in that we've provided a name to called milliseconds per degree. All right, and so let's think about this. If we had if our initial position was, say, like this case here, if our initial position was 180 and we need to go down to 0, what would happen is angle would be 180 and target position would be 0. And 180 would not be less than or equal to 0. So it would skip over this for loop right here, right? So if we're going from a larger angle to a smaller angle, this condition wouldn't be satisfied and it would skip over this and then go on down to here, and then it would execute this the correct number of times. So this would work the way that we wanted it to. We could also add, another way of approaching this would be to add like an if statement to say, okay, if the initial position is smaller than the target position, do this. Or if the initial position is greater than the target position, do this for loop. But the way that we have it right here should work. Okay, so let's try this out. So what I'm going to do is I'm going to get rid of this code here, and we are going to now make use of our function that we defined. So this is called a function definition. We wrote right here in the function what's called header or signature here. We wrote what the function call needs to do, right? So the function call needs to provide us two values inside of here. The first value is going to be the target position. The second value is going to be the milliseconds per degree. And then when we call it, we shouldn't expect a return value because it says void here. All right, and so this is what it would look like to call it. I could say servo move, and then what I do is I pass in one value, some integer target position. So since we say start here at 0, let's say go up to 180, and then we tell it how many milliseconds per degree. So I could say make it go 1 degree every 10 milliseconds. And so that's relatively fast. We could then add another call to our servo move and make it go down to 0, but make it go a little bit slower here. All right, so it's going to go back down to our angle 0 and go in steps of 50 milliseconds per degree. Yeah, so let's see if this works. It should just write and go to 0 at the beginning and then move to 180 kind of quick, then move down to 0 slower using our servo move function that we wrote right here. Okay, so let's try this. I'm going to upload this here and let's pull up the camera. And there we are. Okay, so it says it uploaded. So it moved kind of quicker over this way down to the 180 position, and now it's moving back to 0 at a relatively slower speed. And once it gets there, we see it moves back faster and it goes back there, and that's because our loop is running over and over again. So it moves to the 0 degree position at a relatively slow speed and then moves to 180 slightly faster. And so we can see we're essentially doing the same thing that we just were doing with our for loops, but we've built this function here that we can call, and we can treat it, we know that it'll work because we wrote it to work in this very specific way where we can provide it these two values and it will do what we ask of it. It will move to this target position from the current position declared by myservo.read, and it will do it at this number of milliseconds per degree. So we could call this anywhere now and kind of reduce redundancy in our program. So we don't have these for loops all the way throughout. We just have the for loops right here, and every time we want to use them, we can call servo move.